Let's begin our demo by taking a look at the final objective, which is the ability to be able to assess each of the data lines for signal integrity, being able to see how much eye closure we have, being able to plot things like the DQ to DQS skew, and then using many of the powerful features built into ADS data display, like measurement equations and the ability to do post-processing on the traces we see. As you may remember, this board was first extracted with SI Pro. And this is what SI Pro looks like. You can see it's got a modern 3D user interface. And we've added a new DDR setup wizard. Here you specify the speed grade or the rise time, and it will set the max frequency accordingly, as well as the sweep plan. And then we go and interactively select the memory controller and any of the memory devices that we're going to connect to, and it will determine which nets are connected between them. So it's not easy to forget anything. And then you can go and deselect the ones that you don't want to simulate this time around. And then when we're done with that, we can hit the Generate Setup button, and it will add this analysis to our workspace tree. A massive time saving is the fact that the setup wizard automatically creates EM ports. So here the plus pin is placed on the pad where the component is connected, and the minus pin is the closest ground pin. Now we also created a DDR attribute editor. So once the EM simulation is finished, we can then go and save information into the S parameter file, information that Memory Designer can later use. So for instance, the information we can use is the reference designator of the individual ICs and the net names, which can be parsed into a signal type as well as a signal index. And that's the information that we use back in schematic for Memory Designer to make the automated connections. Now we're back in schematic, let's go and place down the SI Pro generated cell. And it's going to use the S parameters as well as bring forward the reference designators and signal IDs, which we can use to connect to the DDR controller, the memory controller. So also place down a memory probe as well as a block for the memory devices. And now let's push in and instantiate the memory controller. First step, we're using those signal IDs that we had before. Next, we have to grab the reference designator we care about and turn it on. Then we can browse to our IBIS or EBD file. And then now from inside, we get to select, well, which of these signals do I really want to simulate? Then we move over to the model setup tab. And here now we're going to choose what simulation type. So that's going to change the stimulus source, and the speed grade, and then we assign our models as a group to those signals. Since we use the same reference designators and signal IDs in both of these blocks, making the connection with the bus wire is as simple as just pressing one click, auto connect, and the connection is made. Now let's take a look at the memory device, because the memory device is a little special. It could be represented as a single DRAM or multiple DRAM or even an entire DIMM. We have that capability to enable that level of abstraction. So once we've set up the simulation mode and the direction of simulation, whether it's read or write, then we can move into the model selector and choose which particular on-die termination model we want to use. And you can see by the field model alias, we have the ability to specify a variable that we can go through a batch simulation to sweep those values. Okay, so finally now we make the connection between the memory device and it's one click and we are done. So let's move into the memory probe. It's a universal probe, and it means it gives us access to every single signal inside those DDR components. So I can select individual signals that I want to add, or I can add them all as a group. And then the measurements, I can select the measurements and apply them as a group, or I can set them individually if I choose to. Then when we move to reference signal, this is where the memory probe makes an intelligent decision about which strobe relates to which DQ, so that if I want to do something like a strobed eye, it would automatically have that set up for me correctly. If the memory probe is set to perform compliance tests, then what happens is we invoke Keysight's Infinium offline software. It's exactly the same software as what you would use on a scope to make measurements on a real signal on the bench, but ADS completely automates and controls the Infinium software and the DDR4 compliance app. So here the DDR4 compliance app is making measurements, and you see that for one of the measurements we have a small amount of margin, and then it records how many measurements were made, the standard deviation for those measurements, and also on which line we had the worst amount of margin. And it shows us that for the DRAM chip U60 on command address 11, this is where the smallest amount of margin was recorded. You can see that clicking on the waveform, it shows you exactly where in the waveform that measurement was made, the one that had the worst amount of margin. And next, we also get a complete DDR4 compliance test report, where all of the measurements that were selected are then generated as a PDF report. And this could be used for documentation for detailed sign-off. And this now concludes the end of our demonstration.